we have this problem. A particle moves according to a law of motion. This position function s is equal to f of t, and we have given that this function is equal to t cube minus 8 square plus 24t, where time is t is greater than or equal to 0. Find the velocity at time t. And the velocity function is the derivative of the position function, correct? So let's find the velocity. We have this position function s, which is equal to f of t given, right? Which is equal to this. So we can just get straight to the point. The velocity of this function with respect to t is simply the derivative of this position function. You can write this as this, or ds over dt, which is equal to power rule here. Bring the power down in multiplication, subtract -1 from it. So it's 3t square minus, same thing again, 8 times 2 is 16t, and derivative of 24t is 24. So we have the velocity here. Now, what is the velocity after 1 second? So we have already found the velocity function here. Now let's plug in the value in it. Velocity after 1 second, v of 1 is equal to 3, 1. Just plug in the value. It could be any here, 4, 2, whatever is given in the question to solve. So this is equal to 3 minus 16 plus 24, which is equal to 11. And don't forget to write the units of it, feet per second, because s is in feet and t is in seconds. Okay, now let's look at when is the particle at rest. At rest means this velocity function is equal to 0, correct? We have 3t square minus 16t plus 24 is equal to 0. And let's see how can we simplify this. 624. What are the factors of 24? What if we take 3 common here first? No. 14 plus 2. Let's see. What if we write this as negative 14t negative? No. 3 is not factor of this. So as we have concluded that this quadratic equation does not factor. So if you remember the two basically the one formula is mostly used, but there's another trick, the shortcut. We can use it as well. The first is quadratic formula, right? Which is simply, in this case here, t is equal to, so remember the quadratic formula, this is a coefficients of this b, c, so it's gonna be negative b plus minus square root of b square minus 4ac, the whole equation divided by 2 times a. and you just plug in the values here. And yeah, okay, let's get this done. So b is 16 here, negative 16 plus minus square root of b square, 16 the square, minus 4 times a is 3, c is 24, divided by 2 times 3. So you will end up with this negative 16. I mean, you can use calculator here. Plus or minus. This is going to be negative 32 divided by 6. Since negative 32 is not a real number, so there are no real values of t, right? That makes velocity 0. Therefore, the particle is never at rest. And other shortcut, before you go through this, is the shortcut for this is use the discriminant. Check the discriminant first. Basically, d is equal to v square minus 4ac. You're just solving just this, what's inside the square root here. And same thing here, right? You will end up with negative 32. And if you remember the discriminant shortcut, if d is less than 0, that means no real solution. And if it's greater than 0, yeah, you'll get two factors, right? So you will have two real solutions. Otherwise, if d is equal to 0, then it's one real solution. Basically, we're ending up with the same determination. So either way, you can use whichever you feel comfortable with. Okay, let's move to the number d. When is the particle moving in the positive direction? We just concluded that the particle is never at rest, right? Because the velocity never becomes 0. So we conclude that the particle is always moving in the positive direction. Okay, let's look at number E now. Find the total distance traveled during the first 6 seconds. Make sure you're paying attention. It's saying find the total distance traveled during the first 6 seconds. This means the total distance, which is simply the change in position. So we are going to plug in to find the distance and plug in the values in the position function, not in the velocity function, which only tells us how fast a particle is moving in a particular direction. So the distance, you're finding the distance, total distance is simply the first 6 seconds, right? Between the total distance traveled between when the particle at the first 6 seconds and the position of the particle at 6 and at 0. So just plug in the value in the function. So you will end up 6 cube minus 8 times 6 cube plus 24 times 6, and you can use calculator and you'll end up with 72 feet. And make sure you're not writing this feet per second. This is not a velocity function. You're not asking how fast this particle is moving in a particular direction, right? So this is simply the movement of the particle, the distance. And at 0, right? This is simply 0 times 0, 0 is 0 feet. So the distance traveled during the first 6 seconds is basically 72 minus 0, which is equal to 72 feet. And draw a diagram to illustrate the motion of the particle. Since we just concluded from D that the particle is always moving into the positive direction, because the particle is never at rest and the velocity is never zero. So the simplest diagram, and we have noticed that between the distance 72 feet, so the position of the particle from here to here is concluded it's moving to the right direction. Find the acceleration at time t and after 1 second. And acceleration is the second derivative of the velocity function. So this is going to be or you can write down this as you can check my previous video as well for finding the second derivative. Okay, so we have the velocity function 3t square minus 16t plus 24. So the second derivative acceleration at time t is equal to 60 minus 60 16. And it's also don't miss the second part here. Find the acceleration at time t. This is simply the acceleration at time t. And we are asked about after 1 second as well. So you just plug in the value here. This is 6 minus 16, which is equal to negative 10 feet per second square. Now this is the acceleration, so remember the units for it. So this is the answer, and I hope this makes sense. Thanks for watching.